Hi, today we're going to cover a few examples of taking derivatives of exponential functions. So we have the rules here in yellow, and they give us two different versions. So one being the simple rule for if you have a function e to the x, and that derivative is just the same function e to the x. But the other one, when you have a composite, when you have a function inside of that e to the x, so in which case you have to use this chain rule version. Okay, so here's our example. So starting with this first one, we're going to get the derivative of this function, and so our dy dx, we'll just go term by term. So this is nothing new. The derivative of 8x would be 8. The derivative of the minus 7 is 0. And then the derivative of 2e to the x. So the 2 being a coefficient is just going to stay there, just like our coefficients of other functions. And then our derivative of the e to the x remains e to the x. And that's it. That's our derivative of our function. Nothing special in that example. Our next example has a little bit more complicated of a function. So you notice on this one we have 5e to the 4x minus 1. So that 4x minus 1 is a function, a linear function that's in my exponential function. So this is going to require a chain rule. So my derivative, my dy dx, the 5 being a coefficient stays there. And again, I'm using the second rule, so the derivative of e to the 4x minus 1 is the same e to the 4x minus 1. That doesn't change, but times by the derivative of 4x minus 1. So the derivative of 4x minus 1 is 4. So that's a chain rule. So the derivative of the outside times the derivative of the inside. Okay, and then just do a little combining here. I can take the 5 times 4. Since this is all one term, let's make that a 20 e to the 4x minus 1. All right, there's that one. The next example, our third one, is the last one we'll do, and it's very similar to the last one we did. It has a coefficient of a half, and inside of the e that has a function of negative 8x squared. So again, I'm going to have to do a chain rule. So I start with my dy dx. The 1/2 stays where it's at. The derivative of the e to the negative 8x squared is the same, e to the negative 8x squared. I just have to multiply that by the derivative of the 8x squared, which I do a power rule, 2 times negative 8, negative 16, lower by 1, x. That's it. There's my chain rule. Now I'll just do a little bit of cleaning up on this thing. Let's take the half and multiply by the negative 16. Let's make that negative 8x, and then keep my e to the negative 8x squared. So again, if the e to the x, if it's just an e to the x, you just leave the derivative as e to the x. If it's e to the something with the x, like in this case a 4x minus 1 here, or in this case a negative 8x squared, then you have to apply the chain rule. Thank you. I hope this has been helpful.